Good morning, my dear students. Our new lesson 7.3 is talking about integrating trigonometric functions. And we have two rules here. The integral of sine to the power of n, like n to the power of 5, to the power of 6, to the power of 7 of x dx equals negative 1 over n sine n minus 1 of x cosine x plus n minus 1 over n integral of sine n minus 2 of x dx. The second rule for cosine, powers of cosine, like cosine n, cosine to the power of n of x dx equal 1 over n cosine n minus 1 of x sine x plus n minus 1 over n, the integral of cosine n minus 2 of x dx. Okay, let's start here some examples and let's apply these two rules. The first example, how to find the integral of sine squared x. How to find the integral of sine squared x. We have studied this question before, but we evaluated this integral by using trigonometric identities. But today I'm gonna use this way to find the value of the integral of sine squared x dx. The rule first, I'm going to write again the rule, which is negative 1 over n sine to the power of n minus 1 of x cosine x plus n minus 1 over n, the integral of sine again, but n minus 2 of x dx. So let's solve here the question. Sine squared x. So the answer will be negative 1 over 2, such that n is 2. N here is 2. Negative 1 over 2 sine only, because 2 minus 1 is 1. It will be sine x cosine x plus 2 minus 1 is 1 over 2, again 1/2, the integral of sine 2 minus 2, which is 0, sine to the power of 0, yes, sine to the power of 0 of x dx. So the answer equals negative 1/2 sine x cosine x plus 1/2, the integral of anything to the power of 0 is 1. So we have only the integral of dx. My final answer is negative 1/2 sine x cosine x plus 1/2 x plus 1/2 x plus c, the constant of integration. This is the first question. Let's apply here this rule, but for cosine squared x, I'm gonna write first the rule. We will write first the rule. The rule is the integral of cosine to the power of n of x dx is equal to 1 over n only without negative cosine n minus 1 of x sine x, and this plus n minus 1 over n, the integral of cosine n minus 2 of x dx. So it's now equal. It's equal here. 1 over n means 1 over 2 cosine to the power of 1x, since n is 2 also, so 2 minus 1, which is here 1 sine x plus 2 minus 1 here is 1, and this all over 2, the integral of cosine, the same 2 minus 2, which is 0 of x dx equals 1/2 cosine x sine x plus 1/2, the cosine to the power of 0 is 1, as you know, the integral of dx. So the final answer is 1/2 cosine x sine x plus the integral of dx means the integral of 1, which is x, plus the constant of integration. This is our second example. So simply write the rule and substitute in the rule. One more example, but when the question asking to find the integral of cosine to the power of 4 of x dx, the first step is to write your formula, which is 1 over n cosine to the power of n minus 1 of x sine x sine here x plus n minus 1 and this all over n, the integral of cosine n minus 2 of x dx. This is the rule. How to find the integral of cosine to the power of something, to the power of 4, to the power of 5, like this. When you substitute in the formula, we have 1 over 4 cosine 4 minus 1, which is 3, of x sine x, plus 4 minus 1, which is 3, and this all over the n itself, which is 4, the integral of cosine to the power of 4 minus 2, which is 2, of x dx, equal 1 over 4 cosine to the power of 3x sine x stay the same, plus 3 over 4 as a constant, and then cosine squared of x. We can use here identity, or we can apply again this rule. What is this rule? This one. 1 over n cosine n minus 1 of x sine x plus n minus 1 over n integral of cosine n minus 2 of x dx, again here in this part, which is here 1 over 2 cosine x sine x plus 2 minus 1, which is 1 over 2 again, the integral of cosine 0 of x dx. Okay, the final answer is 1/4 cosine to the power of 3x sine x sine what? X plus 3 over 4. Now we can multiply here 3 over 4 by half and distributive property by first and by second. So we have 3 over 8 cosine cosine x sine x cosine x sine x plus 1/2, and then the integral of dx only, since cosine to the power of 0 of x is 1. So the integral of dx, which is x. But don't forget that you should multiply by 3 over 4, and the integral of dx is x, and this all plus c. The last step is only to combine like terms. If we have cosine to the power of 3x sine x plus 3 over 8 cosine sine plus here 3 over 8 again x plus c. One more example for the integral of sine to the power of 4x dx. I'm gonna write first the rule. Yes, here. The rule is negative 1 over n, since it's a sine, then sine to the power of n minus 1 cosine x plus n minus 1 over n, the integral of sine to the power of n minus 2 of x dx. This is the rule. Our answer will be equal negative 1 over 4, then sine to the power of 3x, here is x, cosine x, plus 4 minus 1 is 3 over 4, the integral of sine to the power of 2 of x dx. The first part stays the same, which is negative 1 over 4, and sine cubed is 1 minus, we can write it as sine squared and sine, and then change sine squared as 1 minus cosine squared, So we have cosine x, or leave it like this, it's better to leave it like this here, which is sine cubed of x cosine x plus, and then integrate this part 3 over 4. But this time I'm not gonna apply this rule for the second time as the previous example. No, I'm gonna use this identity. You know that sine squared of x is equal to 1/2 into, yes, do you remember this one? Yes, it's called a double angle, right? We change it to like sine squared of x is equal to 1/2. We reduce here the power. We reduce the power. It's power 2, so we can reduce the power by using trigonometric identities. So it's here. I know that you remember this identity. 1/2 into 1 minus cosine 2x. Yes, it comes from the double angle identity. Cosine 2x is equal to, yes, it's 1 plus 2 sine squared x. So sine squared x is equal 1/2 into 1 minus cosine 2x dx is equal to negative 1 over 4 sine to the power of 3x cosine x plus, we can write it now as a 3 over 8, because 1/2 is a constant, we can take it outside or behind the integral sign. 1 minus cosine 2x dx. Again, negative 1 over 4 sine cubed x cosine x plus 3 over 8, and the integral of 1 is x, so we write 3 over 8x, and we'll multiply by using distributive property, minus 3 over 16. Excellent. You know why? Because the integral of cosine is sine, the integral of cosine 2x is sine 2x, and this all over 2. And 2 times the denominator 8 is 16 now. Okay, and this all plus c, the constant of integration. Thank you.